Now let's discuss the next problem, which is guess the winner. Right. So in this problem, Alice and Bob are playing a game, and they start with an integer n. So in each turn, they'll be taking an odd prime factor of n, and then they'll be subtracting that particular prime factor from the given number n. And in the next turn, the new n will be n minus p, and this should be continued until when one is not able to make a move, which is when there's no odd prime factor or n has become 0. So the player who is not able to make a move will be the loser of the game, and we have to predict who wins the game if both are playing optimally. So actually speaking, this is a very simple problem, but if we try to deviate from the actual observation or the idea, then it will be consuming you a lot of time just to arrive at the solution. So all we had to notice is whether the number is odd or even. So it's given that we have to always get an odd prime factor of n, and then we have to subtract it, right? So let's say we have the number as say 14. Now Alice will be starting it, and then the prime factorization of 14 will be 2 into 7, right? So there'll be only one odd prime factor. So we'll be taking the 7, and then we'll be subtracting it, right? So if we subtract 7 from 14, then 14 will be turning into 7, and the 7 will be having the prime factorization as 1 into 7, right? Now this is Alice's move, and this is Bob's move. Now Bob will be trying to subtract 7 from it, and then the number will be becoming 0, right? So it will be Alice's move now, as Alice is having a number which is 0, so she won't be able to do any operation. Hence, Bob will be winning in this particular case, right? Now, let's just leave alone the prime factorization part, and let's just think about in the sense of odd and even, right? So let's say Alice is being given an even number. Now, whenever the n is even, we'll be trying to take some odd prime factor, and then we'll be subtracting it, right? So initially n was even. Now in the next move, she'll be taking one of the odd prime factors and she'll be subtracting it, right? So when we subtract an odd number from an even number, then the result will definitely be an odd number, right? So Bob will be provided with an odd number. Now, if someone wants to win the game, then he has to take the whole number as the prime factor, and he has to subtract it. In the sense, if Bob is given the value of 7, then he'll be taking the whole number 7 as the prime factor, and he'll be subtracting it, right? Hence the number will become 0, and he'll be winning the game. Now same goes in the case of 11. So if Bob is provided with the number as 7, I mean 11, then he'll be subtracting the whole number and he'll be doing it. So what I'm trying to say is, only if the current person is having an odd number, then he has a chance of winning. So if he has an even number, then he'll be subtracting some number, and he'll be giving the other number, I mean other person, the odd number, right? So Bob has a chance of winning. He has a chance of winning just because he has an odd number. So I'm not saying that Bob will be winning, but he has a chance of winning because he is having an odd number. Now he'll be again taking one of the prime factors, odd prime factors of n, and then he'll be subtracting it, right? So if you subtract an odd number from an odd number, then we'll be getting an even number. So the n, I mean the transformed n, which let's say it's n3 at this step. So let's say this is n1, and then n2 is odd, right? As it's evident from here. And then as we are subtracting an odd number from an odd number, then we'll be getting an even number, and this is Alice's step. So Alice is again posed with an even number, and as we know, as we are just subtracting odd numbers, she doesn't even have a chance of winning, right? So if someone wants to win the game, then it should be Bob, because only he is getting the chances of odd numbers. We should not be concentrating upon the prime factors as such. We should be just concentrating upon the odd and even parity. So if there is an odd even number, then that particular person will be losing the game. So if n is an even number, then Alice will definitely lose the game, which makes Bob as the winner, right? Else Alice will be the winner. Now there is a small edge case. Now what will we do when the given value of n is 1? So whenever Alice is having an even number, then she'll be losing it, which means that whenever she gets an odd number, then she will be winning it, right? But in the case of n being 1, there is no odd prime factor for 1 which can be subtracted from it, right? So even in this case, Bob has to win. So what I'm trying to say is, whoever starts with an odd number will be winning it, and whoever has an even number will be losing it. And even in this case, as Alice will be losing, so we'll be making this if condition as n equals to 1 or n is an even number. So in the case of n being 1 or n being even, Bob will be winning it. Otherwise, Alice will be winning it. So that's exactly what I have done over here. If n is equals to 1 or n is an even number, then Bob will be winning it. Otherwise, Alice will be winning it. Now let me just submit this code and then check verdict. So yeah, this code is getting accepted. So this is how we can solve this problem. So that's why I said in the beginning. So this is a very simple problem, but if you get deviated from the actual observation, then you'll be taking a lot of time. You'll be spending a lot of time to solve this problem. So instead of concentrating on the prime factors, you should actually be looking at the odd and even cases. So this is a solution for this problem.